Hi guys, welcome back and let's solve another Leetcode problem today. The problem we're going to be looking at is flood fill. So for this problem we're given an image represented by an m by n grid of integers. So we have this grid here and it's filled up with these integers. And if we take one particular index position from this grid, that gives us the pixel value at that spot. So we have all of these pixel values across the grid to form the image. And we're given three integers. So we're given an SR, SC, and a color. So SR is the starting row, SC is the starting column, and our task is to perform a flood fill on the image starting from the pixel at SR, SC. Okay, so the first thing we can notice is this is actually a 2D array. And essentially a flood fill just means that for the starting pixel that we need to look at in our image grid, we take that pixel and we check all of the horizontally and vertically adjacent pixels. So we check up, down, right, and left. So we don't check any diagonals. And once we've checked all of these pixels, we need to also check, do these adjacent pixels match the same value that currently exists in the pixel that we're looking at? So in the starting pixel, we have a value of 1. So that essentially represents the color. For these adjacent pixels, we can see that for the one above and for the one to the left, both of these pixels have a value of 1, but the pixel below and the pixel to the right, they don't have a value of 1. We're only interested in the pixels where the numbers match. Okay, so once we've identified which pixels we're interested in, what do we actually do? Well, we just need to update it to this color attribute that we've been given. Currently, we can see that the pixels we're interested in is the starting pixel and also these two pixels that are adjacent. These get modified to a value of 2. So as I'm highlighting here, we can see that these values have been modified to 2. But notice how the value below and the value to the right, they stay the exact same. Hopefully this makes sense. This is essentially what the flood fill wants us to do. But I'll go through this example again, discuss it from an algorithmic point of view for how we can implement this. And I think that should give more clarity on what this problem is asking for and how we can solve it. Okay, so here I've rewritten the grid, and the first thing we can do is, since we've been given a starting row and a column, let's just write it down here. So starting row and starting column. And for this problem, let's just assume that the start is the center of this grid. So we'll say starting row is 1 and starting column is 1. Because this is a 0 index grid, and let me just add labels on this grid to show which row and column we're at. So, all right, there we have the grid, and we can see that the starting row 1 and the starting column 1 points to the first column and the first row. So the value at this position would be this one here in the middle. Here we can see that the color at the starting position is a value of 1. So for this problem, when I refer to the color, it's just simply referring to the value of the pixel, so the number that's in the pixel position. Starting color is 1. And we've also been given a color attribute in the problem, so we've been given color as 2. So now, there are mainly 3 steps to how we can solve this problem. Okay, so the first step is looking at the pixel value that we're currently at. We need to check if it's within the boundaries of the grid. So here we can see for this pixel position, we're well within the boundary of the grid, as we're not below the lower bound of the row or the column, nor are we above the upper bound of the row or column. So the first step is check the boundary. So as part of this first step, we can also do another check, which is for this current pixel that we're looking at, we'll also check if the value at that position is equal to the starting color. We're checking, does the value at this position match the value of the starting color? We'll just add it as a step here. So check value matches. We've done 2 main checks as part of the first step. Now let's move on to the second step, where now we know that the position that we're looking at, the pixel that we're looking at, has a value that matches the starting color. That means that we can modify its color to the new color that we need to eventually output. All right, that's the second step. And now finally, we have one last step, which is to check the adjacent pixel values or the neighbors. So as part of the third step, we'll have check adjacent pixels, which are our neighbors. So we have the 3 steps written down here. Now we can actually go through this. So let's go through this step by step. Starting with this first pixel, we can see that it's within the boundary and the color matches the starting color. So we can move to step 2, which is to modify the color. So let's modify this to now be 2. And then the third step is to check the adjacent pixels. So we can check up, right, down, and left. These are the pixels we need to check. One key thing that I forgot to mention was after following through each steps 1 to 3, we need to actually repeat the steps for all of the neighboring pixels. So now let's take a look at the pixel above. So our focus is this pixel now, and we need to repeat the same steps again. So we check, is it within the boundary? And does the value match the starting color? It satisfies both of these conditions in this case. So we can move to step 2, which is to modify the color. So we'll make this value 2. And then again, we check the adjacent pixels. We need to check above, to the right, below, and to the left. Okay, so here, since we're also checking the pixel above, which would be around here, we can see that this is clearly out of the boundary. So we failed the first check that we need to do, which is this. And as a result, we can skip executing. So we just return out of this check for the pixel above. So now we can check to the right. So we can focus on this pixel here. And we can see that it's within the boundary and the value matches the starting color. So we can move to step 2, which is to modify the color. So that would go to a value of 2. We take the adjacent pixels, which is up, right, down, and left. If we look at the pixel above, we can see it's out of bounds. So we would return out of that. And similarly, if we look at the pixel to the right, that's again out of bounds. So we return back. Now, looking at the pixel below, we can clearly see that this is within the boundary, but it fails the second check, which is that the value that's within this cell doesn't match the value of the starting color. So as a result, we can't continue because we failed the first check. So we would return out. So essentially the pixel value stays as 0. All right, so I'll just remove the mark to show that it's returned. And now again, we're back at this pixel and we've got one final direction left, which is to the left. And because this pixel has already been visited, we don't need to worry about it. We can erase these markings here to show that that has been handled. Looking at this pixel, we've already checked in the up direction and the right direction. Now we check in the direction below and we can see this pixel has already been visited. So again, we just return out. And finally, we need to check to the left side. So we need to check this pixel. And now we perform the same steps 1 to 3. So step 1, we can see it's within the boundary and the value matches the starting color. So we can move to step 2, which is to modify the color. So this gets modified to a value of 2. And we move to step 3, which is check all of the adjacent pixels. Up, we can see it's out of the boundary, so we return out. To the right, we can see that we've already visited this pixel, so we can return out. Looking at the cell below, we can see that it's within the boundary and it has a value of 1, which matches the starting color. So this value now gets modified to 2, and we need to check the adjacent pixels. So we check up, right, down, and left. Now notice how this whole pattern of checking is kind of recursive. So we're repeating the same steps and we're kind of following a depth first search approach. We're zooming in on one cell and going to the deepest level possible before we step back out and work our way backwards. Now focusing on this pixel, we know that above we've already visited this pixel, so we can return out. To the right, again, we've visited this pixel, so we can return out. And looking at the pixel below, we can mark it as we haven't visited, and we can see it's within the boundary and it matches the color for the starting color. So this will get modified to a value of 2. And yet again, we're faced with another recursive step. So we need to check the adjacent values for this pixel. Okay, so up, we have a pixel we've already visited. So we return. To the right, we can focus on this pixel here. And we can see it's within the boundary, but the value doesn't match the starting color. We can return out because we've failed this first check. Now we look at the pixel below, and this is out of the boundary, so we've again failed the first check, so we return out. And finally, we check the pixel to the left, which is again the exact same situation. And for this particular pixel, we've exhausted all of the directions. So let's just erase all of these markings to show that we've handled that pixel. And again, looking at this pixel, which was where we were at, the only direction left for us is the left side, for which it's out of bounds. And since we've exhausted all of the directions for this pixel as well, we can remove all of the markings, and that completes step 3 for that pixel. Now going back to this pixel, we can see that the final direction left for us is the left side. And again, this would be out of bounds, so we return out, and we can remove the markings here to show that we've exhausted all of the directions. And again, it's the same situation for this pixel as well. Okay, and now for this pixel, the only direction we explored was above. So now we need to check to the right. So we focus on this, and you can see where this is going. So we've failed the first check, so we return out, and then we check pixel below. So the focus is this pixel, and again we failed the first check, so we zoom out. And then we check this pixel, and we can see that the value of this pixel now is 2. So the value no longer matches the starting color, so we simply just return out. And with that, we've actually exhausted all of the directions, and we'll remove all of these markings. And here we have the final output after applying the flood fill. If we compare it against the expected output from Leetcode, we can see that it matches perfectly, and we can return this output. Okay, so that actually covers the explanation part. So it's quite a long explanation, but hopefully it made sense. And let's go ahead and implement this in code. All right, in terms of the function here, we've been given image, which is the 2D array that contains the pixel values. We've been given SR and SC, which are the starting row and the starting column. So this is the position of the starting pixel that we need to look at. And we've been given this color parameter as well, which represents the new color that we need to modify to. All right, so within the function, the first thing that we can actually check is if our starting color, so the color at the starting position, if it matches the new color, then we know that we actually don't need to modify anything. So this is the first check that we can do. But for this, we need to define the starting color, and we can define this as the value that is at the position for the starting row and the starting column. So we index the 2D array like so, and that will get us the value at that position, which is essentially its color. And now we add the check. So if starting color matches the new color, then we can just return image as it is without modifying anything. Okay, so with that first check out of the way, we now move on to the main chunk of the code, which is the recursive function. And from the first part of the video, we know that this is like a depth first search. So we'll define this function as DFS, and we'll give it the row and column index positions. So now within this depth first search function, there are 3 main steps that we need to take care of. For the first step, we're checking if the value is within the boundary. So if these index positions are within the boundary, and we're also checking if the value at this position matches the value of the starting color. We need to make sure that the row value is actually between 0 and the maximum row that we have in our image 2D array. So we need to make sure it's between 0 and the length of the image. So this will get the number of rows from the image 2D array. And similarly for the column value, we need to make sure it's between 0 and we need to get the number of elements within a single row. So that represents the number of columns we have, which would just be the length of image 0. If it satisfies both of these conditions, then that means that it's within the boundary. But instead, we can again use a reverse approach, and we can check if it doesn't satisfy these conditions. We know that it's outside of the boundary, so we'll just return out of the recursive function. So this will essentially be the base case for our recursive function. So if row is less than 0 or row is greater than the length of image, then we know it's out of bounds. And similarly, we'll continue this condition. So we'll have or column is less than 0 or column is greater than the length of image 0. So this is the max number of columns that we can actually have. So this essentially performs these checks. Now the final check we need to include within here is if the value at this current position that we're looking at doesn't match the starting color. Then again, we know that we can return out. This is like the case where we're looking at a 1 and we see the adjacent cell doesn't match that value, so it's a 0, and we just return out. So if image of R and C not equal to the starting color. So below these sets of conditions, we can just return. So this is our base case for our recursive function. We've performed the check to see if it's within the boundary and if it matches the starting color. So if it satisfies both of those conditions, we move to step 2, which is actually modifying the color. So we would take image R and C and we would update it to the new color, which we get from our parameter. All right, so that handles modifying the color. We move to step 3, which is the final step. And for this step, we check all of the adjacent pixels. So we need to check the horizontally and vertically adjacent pixels. And here is where we include the recursive case. So for the case of checking the up direction, how do we get one value above the current pixel value that we're looking at? So we have R and C, R representing the current row that we're in. And if we just subtract the R value by 1, we can go to the row above. So it's actually just as simple as that. So we're calling the same function again, but we're subtracting 1 from R, and we keep C just the same. And this will check the case for the pixel value above. Now let's repeat this again for checking the pixel value below. And in that case, we would increase the value of the row by 1. So R plus 1, and then we keep the column the same. So that will check down. Now to check the pixel value on the left, we would take the exact same function and we would keep R just the same, but we would subtract the value of the column by 1. So we need to look at the column before, which means we reduce the value of the column by 1. So C minus 1. And finally, we need to also check to the right. So we take row as the same and we do C plus 1. All right, and believe it or not, that is actually just pretty much it. So this will perform the recursive neighborhood check. So this is checking all of the adjacent pixels. And because we're calling the same function again, it also handles performing the same steps for those respective pixels. So this is the beauty of recursion. And outside of this function, we just need to trigger the first function call, which is DFS, and we pass in the starting row and the starting column positions. And after this function completes performing all of the steps, in the end, we just return image. So this will return the modified image with the flood fill applied. Let's copy this code over to Leetcode and let's test it out. There we have it, guys. So we've passed all of the test cases. And in fact, we have a solution that beats 100%. And in terms of the time complexity here, we have big O of the rows times the columns. So this is the size of the image because we're looking at each position in the image exactly once.